Hello student, my name is Nimesh Prabhakar. I am Assistant Professor at LJ Institute of Engineering and Technology in Instrumentation and Control Department. Welcome to Process Control Lecture Series. Today we are going to discuss about servo and regulatory control, and then after we see the stability. In my previous lecture we discussed about the classification of variable. Now in this lecture we first start with the servo and regulatory control. So first of all we see the objective of control system is one of the following. That means first one, objective of any control system is elimination of disturbance. That means to reduce disturbance or to eliminate that disturbance. So that can be achieved by using regulatory control. So regulatory control system help to eliminate the disturbance. And second one objective of control system is making the control variable flow the change in set point. That can be achieved by using servo control. So these are the main basic control of any control system. So here first one is the servo control and second one is the regulatory control. Now we understand one by one. First one we start with regulatory control. So in regulatory control, in this case deviation of the output from the set point is minimized in the case of changing circumstances by adjusting the input to the system. That means here we take one example to understand this regulatory control. Now we have to control the temperature in the room. So here objective is to control the temperature of a room. So we set one point, set point of for this is a 25 degree. That means we want 25 degree centigrade temperature constantly in our room. So now because of some disturbance this temperature is increased and go to the 27 degree. That means here deviation is 2 degree. Now to reduce this deviation, or in other words to achieve our desired temperature, we have to eliminate this deviation. So to eliminate this deviation, now controlling system start the compressor and try to reduce the temperature of this room. Now we know in AC when condenser is start, then temperature is reduced. That means here temperature is reduced by controlling action and we get 25 degree temperature. Now second one type of controlling is servo control. As per definition, in this case the aim is to get the control to flow a desired trajectory specified by the input. That means this control system is used in the tracking of missile and aircraft, because at that time of launching of missile or launching of missiles, the trajectory that is of missiles that follow that path is very much important. So this type of control system is used for tracking of missiles and also tracking for the aircraft. Now also the second one is the guiding the direction of spaceship. This control system is used. Now to understand this control system, let's take one example, like local example. So here this is our LJIT college, and we want to launch one missiles, and the launching point of this missile is our LJIT, and destination point for these missiles is the Sivranjani crossroad. So, but here the missiles must follow the given path by the input. That means missiles must follow the path like LJ to SC highway, from SC highway to ISKCON, and ISKCON to Sivranjani crossroad. That means these missiles must follow this path. That means first it passed through YMC crossroad, and then it passed to the Praladnagar crossroad, and then it come to the ISKCON, and then it go to the Sivranjani. So this type of control can be achieved by servo control system, because in these we control the specific trajectory of path defined by the input, because here our trajectory is finally defined before this, then the path must be followed by the missile this. So to regulate this path we need one control system, and that type of control system we can achieve by using servo control system. So these are the main two type of control system. First one is the regulatory control system, and the second one is the servo control system. Now stability. So first of all, question occur in mind, what is stability, also why we require stability, and what is the stability of system, or what is the stability of any process. So now we understand by this lecture. So first of all, stability. A system is defined as stable if the control variable converges to a steady state after the disturbance. Otherwise the system is unstable. So this is a simple definition of stability. Any system is called stable if that system control variable converges to a steady state after some disturbance. If that system that variable not go to the steady state, then this system is called unstable system. Now to understand this, let us one example and see in this graph. In this graph, consider the behavior of variable x shown in figure. Notice that at time t is equals to t0, the constant variable is changed, like is the time t is equals to t0, the value of x disturbed by some external factor, but that as time progress, the value of x return to its initial value and stay there. That means at t is equals to 0, the value is changed, but after some time this value is steady. So this type of system is known as steady system. Now if we consider this x is a process variable such as temperature, pressure, concentration or flow rate, we say that the process is stable or self-regulatory and need no external intervention for its stabilization. So it is clear that no control mechanism is needed to force x to return its initial value. So this is a simple stability system. Now to understand more, we take another example, like other system is represented by this graph y. In contrast to the behavior described above, the value y the variable y is shown in this figure. Figure does not return the variable value not return to its initial value after it disturbed by external influences. See here, the value is not returned to its state after some disturbance at t is equals to 0. Process whose variable follow the pattern indicated by y in this figure is called unstable process and require external control for the stabilization of their behavior. So this is a stable, the left hand side graph is represent the stable system and right hand side graph is represent the unstable system. Here we see the after some deviation the value is come in a steady state, but here after some deviation value is not come in a steady state. So because of this reason, so this is a unstable system and this is a stable system. Here x and y is represent the variable, that means anyone, temperature, pressure, anything. Now to understand more stability, by using a transfer function we can also define the stability of the system, like if closed loop poles are located in left hand, then system is known as stable system. That means we understand by using one example. See here, the one system transfer function is given by C of s upon R of s is equals to 10 upon s plus 2 into s plus 4. Now we can find out the pole of this system. We know the pole of this system is the s is equals to minus 2 and s is equals to minus 4. So these two poles and the representation of these two poles in the left hand side, we know this is the real axis and this is a representation of these both poles, we know. So by definition, if closed loop poles are located in left hand, then system is stable. That means this system is known as stable system. And this is a first one minus 2 and this is a minus 4. So this is a representation of this pole. Okay. Now for better understanding, we see the graphical representation of this system. So by solving this equation, we know this system is very exponentially. So at the initial state, the value is deviation, that means oscillate this system. But after some time, this system is try to stable. So this is a steady state. So this is the behavior of this system and graphical representation of this system. So this is a stable system. Now to understand more, we see second one example of unstable system. See here, so one here given the one transfer function C of s upon R of s is equal to 10 s minus 2 s minus 4. So we can calculate the pole of this system. So here pole is the s is equals to 2 and s is equals to 4. Now the graphical representation of these two poles is in the right hand side. That means here for understanding I take only one pole. So here the representation of these two poles is on the right hand side. So by definition we cannot say this system is stable, because by definition the pole must be represented here left hand side. So this is a not stable system. And the graphical representation of this system is like this. So this is an exponential function but in increasing order, exponential function. And the behavior of this system is like at the initial start on oscillation the change, but that cannot return to its steady state value. So we can say this system is unstable because its variable variation is not come in a steady state. So this is a unstable system. Now by using this table we understand more about the stability of the system. So as the nature here the real nature of the closed loop pole like a real negative in left hand of the S plant, that means in the left hand side of this side. So that figure is called the stable, or in other words absolutely stable system. And this is a transfer function representation of that system. So this is a transfer function representation, and this is a stable system if left hand side is pole is present. Now understand more. We take here the imaginary pole is given like 1 plus 2j, 1 minus 2j, but here both pole is present left hand side. So this is also known as absolutely stable system because both pole like here the real pole but here imaginary pole, but these two pole are in the left hand side. So this is a stable system, and this is a transfer function representation. See here, so initially is oscillate but it try to steady state, it achieves steady state. So this is a stable system. And if system is not stable, then we require controller, and by using that controller we can stable the system. And here third one is the unstable system. See, the pole, the real pole is in the right hand side of the coder. So this is because as per definition must be in the left hand side, but here the pole is on the right hand side. So this is a unstable, and this is a transfer function behavior of this system. And this is a complex pole of this system. Here they see the complex pole is also present on the right hand side. So as we discussed about the definition, so this system is also unstable system. So by using transfer function we can also find out the stability of the system. Okay.